So this module 2 is all about transformations. We talked about translations, reflections, and now we're going to talk about rotations. So phones should be away, your full attention should be on this. All right, so properties of rotations, I'll kind of show you the important stuff. So when a figure is rotated a few different ways, like around the origin on a coordinate plane, like 90 degrees clockwise, 90 degrees counterclockwise, or 180, there are rules that you can use. So just like how in reflections, there are really specific rules that you can use, that's the same for rotations. All right, so that goes for 90 degrees clockwise, 90 degrees counterclockwise, or 180. So clockwise, think of, your normal standard clock. We don't have a standard clock in here, but the ones with like the hands. All right, the clock turns this way normally, right? Like the hand moves around that way and it keeps going that way. That's what we mean when we say clockwise. That's what we're talking about in this picture. Counterclockwise would be the opposite. So the opposite way that a normal clock moves. And it also says it right here too in words if you like that better than the pictures. Questions about that? So then for 90 degrees clockwise, here's an example and here's our rule. So I would star and highlight this bottom part. Anytime you have a 90 degrees clockwise rotation around the origin, so around this middle part of your graph, you can simply move the y value to the x value spot. So change the order and change the sign of the x value. So just follow the rule. So like over here, I have my original A coordinate is 3, 3. I'll just write it a little bit bigger. If I wanted to figure out what A prime would be, I would just put my y value first. So this is A. A prime would be whatever my y value is. And then whatever my x value is, just made negative. All right, and doesn't that match what they already have down here? So here's 3, negative 3, that's what I get for A prime. And that's what they did for all of these. So for B, we had 1, 2. Well, if I'm following this rule, what should the first number be in my new coordinate? 2. And my second number should be what? -1. All right, so the y from the original will now be first. The x will be second, but it'll also have a different sign. All right, I like those rules because I feel like they're the most straightforward than just trying to visualize it. All right, so that's the rule for 90 degrees clockwise. For 90 degrees counterclockwise, we are going to follow this rule down here. I would highlight or star this and the rule for it, which is down here. So my original coordinate, if my original coordinate is xy, my new coordinate will now be -y, x. All right, and here's your example. So if my original was 3, 3 for A, then my rotated image would be a negative y value. So my y value is 3. It's now going to be negative. Then whatever the original x value was. And no change to sign there. that does match what we have over here. All right, let's try it with one where the x and y values are different. Maybe you'll see it better. All right, my original, oh, oops, that's not my original. If my original was 4, 1 over here, and I'm following this rule, what should be the first number in that coordinate? -1, and the second number should be, right? Let's do one that doesn't already have the answer on here. Let's say I have point F originally was 7, 2. All right, what would F prime be following this rule? -2, 7. All right, seeing the pattern. Good. All right, so other rule is 180-degree rotation. So if it says in the instructions, this figure is rotated 180 degrees about the origin, then you have a 180-degree rotation, which follows the rule x, y becoming -x and -y. All right, so you're changing the sign that it originally was. So if my original, we'll do the b that's on this triangle, is 1, 2, then my rotated one would be what? -1, -2. So the signs flip. Let's do one that isn't on this picture. Let's say I have F3, -4. What would be my coordinate according to this rule? All right, good. So the signs become exactly the opposite. So since this started out positive, the 3, it becomes negative. If it already starts out as negative, you flip it to positive. So don't get confused by these negatives. They don't have to be negative. It just depends on what you started with. All right, makes sense? All right, so I think this just kind of sums it up. I'm not sure how much in depth I'll go, but just like translations, just like reflections, what we really want to show you is that we're not changing the size or the angle measures, right? The only thing we're changing when we're rotating something is its orientation, right? We're not making one smaller, making one bigger, not changing the angles. So would these triangles be congruent? Right, congruent, remember, has same side length, same angle measures. So I would say yes, these are congruent. Just because you rotate something doesn't mean you are making something new. All right, you're just rotating it. The location of the points might be different, but you know, you're just rotating it. Also, if I have a point that lies between A, B, maybe like in the middle, say my midpoint is E, then it's going to be in the same position on the other triangle. It's going to still be between A and B. So that's called preserving collinearity and betweenness. All right. So then, does not change shape or size is the other important part of this. Questions? All right, so then the next page, we have this hexagon titled gravel is rotated 270 degrees counterclockwise around the origin. What are the coordinates of the endpoints for LG? All right, so did we have a rule for 270 degrees? No, we had it for 90 degrees, both directions, and 180 degrees. Do you know how many degrees it takes to rotate something completely? So if 360 degrees is a full rotation, and we are going 270 degrees counterclockwise, I could subtract 270 from 360 and see if it gives me a rule that I can actually work with. So it's 360 minus 270. $90 degrees. So I was going 270 degrees counterclockwise, so I was going in this direction. I'll kind of write that in. I'm going 270 degrees counterclockwise. The equivalent of that is going 90 degrees clockwise, right? So that completes the 360. So if I do the 90 degrees clockwise rule, I can get my answer for this. Does that make sense? All right, so the key thing here, since 360 is a full rotation, if this does not match one of your given rules, see if maybe subtracting them will. And make sure you're also doing the opposite direction. All right, so the 90 degrees clockwise rule from the pages before says that we are using the rule. Is that in here that noise is so loud? Or is it out there? Jeez, okay. X, Y, Y, negative X. All right, so this is the rule for 90 degrees clockwise, right? Everyone see where I came up with this? All right, this is one of our given rules. So I just need to figure out what all my coordinates were initially and apply this rule to it. Or actually, I really just need to do it for LG, right? Because that's the only one it asks about. It's asking about these 2 points on this side. Make sense? So what was my original coordinate for L? -1, -2. So then L primed would be, according to this rule, -2, +1. All right, so your Y value that you had originally is now first, X value is now second, and it changes sign. All right, try G on your own real quick. Practice coming up with the original coordinate. And then practice rotating it according to that rule. I think on L, I think I counted wrong, sorry. L should be what coordinate? Should be -3, sorry. I just looked at it a little off. Sorry, make sure you fix it. It's actually at 1, -3. Or -1, -3. All right, what's the original coordinate for G? 1, -2. So my new coordinate for G would be -2, -1. Good. All right, and then these would be the only answers I need because that's the only ones it asks for. All right, questions? Sorry if I skip too fast. If you're still writing, finish writing on this slide. All right, we'll do just one more example together, so don't pack up just yet. All right, one more example together, and also don't lose your notes for this because we'll have to finish them on Monday. So here's a rule refresher. Same thing that we've been talking about, just organize in this chart. So I would just write here, use on test, right? Very important. We have 90 degrees clockwise, 90 degrees counterclockwise, and 180 degree rotation. All right, but for our last example, that is on the next page of that. Example 1, we have triangle ABC is shown on the coordinate plane. If triangle ABC is rotated 90 degrees counterclockwise around the origin to create A prime, B prime, C prime, what is the ordered pair of point B? All right, so what rule are we using in this one? If it's 90 degrees counterclockwise. What does the handy chart say it becomes? Negative yx. So if we're only concerned about B, because that's all it asks for is what's the ordered pair for B prime. What was B originally? It was at 2, 2. And according to this rule, what is my new coordinate? Good. So my y value now became negative in its first. X value moves to the second spot, and it stays the same for the sign. Makes sense? Any questions? All right, so once you've copied that down, and once everyone has put their calculator away, you can go. So don't leave until all calculators are back.